welcome to another NGen Math 7 lesson by eMath Instruction. My name is Kirk Weiler, and today we're going to be doing Unit 5, Lesson 5 on combining like terms. All right, now really this is an extension of the last two lessons we did when we were writing equivalent expressions. Combining like terms is just another way of writing or taking an expression that's more complicated, let's say, and writing it as a simpler expression, but one that's equivalent, one that would have exactly the same value no matter what value of the variable you put in. So, before we get into combining like terms, we have to actually review a very, very important idea when it comes to a term in a particular expression. Let's take a look at that important idea, the coefficient of a term. You will see this piece of terminology, coefficient, until you stop taking math. And the coefficient of a term is simply the constant, in other words, a number, just a normal number, whatever, that is multiplying the variable or variables of a term, and that's absolutely key. It is the number that is multiplying, not dividing, not adding, not subtracting, but the number that multiplies the variable or variables in a term. And a term always has a coefficient, right? So let's take a look at exercise number 1. For each of the following monomials, single-termed expressions, state its coefficient. Some terms may need to be written in terms of a product to properly identify it. All right, so again, right, a coefficient kind of tells you how many of those variables there simply are. So when I see something like 5x, it's very simple, right? The coefficient is simply, and let me move this up a little bit, the coefficient is simply 5, right? And again, what that's telling us is that we've got 5 x's being added together. X plus x plus x plus x plus x. The coefficient is 5. Likewise, something like letter B, 3 times y, the coefficient is 3. Piece of cake. Even something like letter C, where we have 1/2 times c, well, the coefficient is 1/2. We literally have a half of that variable, right? Whatever the variable's value is, we have a half of it, right? So its coefficient is 1/2. And certainly coefficients can be fractional, they can be negative, they can be decimal. But something like this is a little trickier, right? The variable n, just sitting there. Well, again, the coefficient tells us how many of the variables there are. And in this case, there's 1, right? 1n. And in fact, we can rewrite this as 1 times n. So its coefficient is just 1. We almost never see something like this, right? 1 times n. Why would we write that? 1 times n is just n. It'd be like writing n plus 0. Why would we do that? The plus 0 really doesn't tell us anything or give us anything extra, right? So we have to recognize that the coefficient of this is the number 1. Now let's look at some that are a bit more, let's say, challenging, right? Letter E, take a look at this. X divided by 5. Now that's much harder, right? Because the coefficient is the number that is multiplying the variable. Now you might say, oh, well, then I'm going to just put a 1 there and maybe the coefficient then is just 1 because it's 1 times x. Well, that's not quite right. In fact, x divided by 5 can be rewritten equivalently as 1/5 times x. These two things are the same. X divided by 5 and 1/5 times x, right, are the same thing. And therefore, the coefficient of this term is 1/5. All right. Now, letter F, that's a piece of cake. -4 times e. Well, the number that's multiplying the variable is -4. Nothing tricky there. It's much trickier if we've got some kind of division going on. Now this one could really throw people off. 2y divided by 7. It seems like the coefficient is maybe 2, right? Because, oh, we have 2 times y. But in fact, right, 2 times y divided by 7 is the same as 2/7 times y, so the coefficient is actually 2/7. And maybe the trickiest one of them all, -n divided by 8, right? Maybe the coefficient's -8, maybe the coefficient's 1/8. Nope, none of those, right? This is the same as negative 1/8 times n, so the coefficient is negative 1/8. And again, coefficients are really, really important to understand because they tell us how many of the variables are there. You know, are there 5 of them, 3 of them, a half of them, 1 of them, 1/5 of them, negative 4 of them? I know that sounds weird. 2/7 of them, negative 1/8 of them, right? That coefficient tells us how many of those variables are present. And we need to know that in order to combine like terms. So let's start to think a little bit about combining like terms. Now, we got some basic building blocks when it comes to understanding combining like terms. The first one we'll see in exercise number 2. Let's take a look at it. For each of the following, rewrite the sum as a product. You do not need to evaluate any of the products. Now, look, this is just a reminder of what products are. Products are repeated addition. So if I have 3 plus 3 plus 3 plus 3 plus 3, that is simply the same as 5 times 3, right? And likewise, therefore, if I've got x plus x plus x plus x plus x, that is the same as 5 times x, right? It's just what it is, right? 5 x's added together is the same as 5 times the number x. Likewise, if we have 7 plus 7 plus 7, 3 7's added together, that is just the same as 3 times 7. And same thing, if I have y times y added together, that is just the same as 3 times y. All right, so very, very easy. Nothing stressful here. If you're thinking, man, this is like Algebra 101 from last year, or 5th grade even, I completely agree. Now let's take a look at building block number 2. Let's go in the opposite direction, right? Exercise number 3. Write each of the following terms as sums instead of products. All right, well, this is easy enough, right? 4 times x, we're just going to reverse what we did in the last exercise, is the same as x plus x plus x plus x. Right? It's just those two things are equivalent. Right? It's just what multiplication is. Why don't you pause the video really quick and do letter B and letter C. They're pretty simple. All right, well, 5 times y, that's easy enough. That's y plus y plus y plus y. Oh y plus y. Right? 5 y's added together. One doesn't look very much like a y. And 2c, maybe that's the easiest of them all, is just a c plus c. Okay? So very, very easy. We're just saying, hey, look, do you understand what multiplication is? 5 times y is 5 y's added up, right? 2 times c is 2 c's added up. Likewise, 4x. Now let's put it all together and understand combining like terms. Here we go. Consider the sum 5x plus 3x. We want to simplify that. Letter A. Write both 5x and 3x as extended sums like we did in exercise number 4. All right, so that's easy enough, just like we did in the last exercise, which I think was exercise number 3, not exercise number 4. But in the last exercise, do exactly what we did, write out 5x as x plus x plus x, etc., and 3x the same. Why don't you go ahead and pause the video and do that? All right, simple enough, right? 5x is x plus x plus x. The more I say x, the stranger it sounds. And 3x, x plus x plus x. Right? All right, that's simple enough. But that means we can now take the sum 5 plus 3x and we can write it as an extended sum and simplify it. Let's actually do that together, right? So 5x plus 3x then will have to be x plus x plus x plus x, whoops, plus x, there's our 5x, right? Plus x plus x plus x, that's our 3x. And when I add them all together, according to building block number 1 in exercise number 2, right, I've got 8 x's sitting here, right? 1, 2, 3, 4, 5, 6, 7, 8. I've simply got 8 x's. Now, you might be saying to yourself, well, of course you do, right? And that's letter C, right? How could we have simplified that sum by using the coefficients of the 5x and the 3x, right? The coefficient of the 5x is 5, and the coefficient of the 3x is 3. So how could we have added 5x to 3x and get 8x? Well, we could do it by simply adding the coefficients together, right? We could have just added the coefficients together. And in fact, please make sure to write this down, right? What we're really saying is that we could take 5x plus 3x, and we could simplify this by doing 5 plus 3 and then multiplying by x. Now, if this kind of looks a little bit like the distributive property, except maybe run backwards, right? Then boy, are you observant, right? So really what we're doing when we do this is we're actually kind of running the distributive property backwards. We're saying, look, I got 5 times x and I've got 3 times x, so I can actually do 5 plus 3 and then do times x. And of course 5 plus 3 is just 8. And it should make sense. Look, I'm keeping track of how many x's there are. If I've got 5 x's and I add 3 x's, I have 8 x's. If I have 5 oranges and add 3 oranges, I have 8 oranges. If I have 5 kittens and I add 3 kittens, I have a whole lot of trouble. But I also have 8 kittens, right? So it really should be that simple to think about. And in fact, let's get some practice with this very simple idea. Like terms, right? So the whole title of this lesson is Combining Like Terms. So let's make sure we understand what a like term is, right? Like terms are those terms in an expression that have the same variable or variables raised to the same exponents. Now, the vast majority of time for us, the exponent is simply going to be to the first power. It's not going to be to the second power or the third power or whatever. And that means something like 7x and 3x, those are like terms because they have the same variable, x, raised to the same power, the first power. But something like 4x and 2y, those aren't like terms. You know, that would be like saying if I've got 4 apples and I add 2 oranges, what do I have? Well, I've got 4 apples and 2 oranges. That's just what I have. I can't really do anything with the 4 and the 2. On the other hand, if I have 7 apples and 3 apples, then I add them together, I have 10 apples, right? And it's really pretty simple. Let's take a look at exercise number 5. Rewrite each of the following by combining like terms. All right, now I would suggest every time, especially until you get used to it, to do the following. Something like 7x plus 5x, I would rewrite as 7 plus 5 in parentheses times x. And then of course that's just 12x. Right? Real simple, but notice how it's almost like I'm doing the distributive property in reverse, right? I'm saying, like there's an x multiplying both of these, I'll put it outside of the parentheses and then I'll just add these two numbers together. The distributive property works with subtraction just as well as it does with addition, and it also works with negative numbers. So something like letter B, 10y minus 3y, would just be the same as 10 minus 3 times y. And of course, that would be 7y. And finally, you know, when we have negative numbers involved, no different, right? We can now say, that's just going to be the same as negative 16 plus 12 times the letter C. If I have negative 16 and positive 12, a bunch of those will cancel, leaving me with a net negative 4. And we have negative 4c, right? So simple enough, right? And all we're doing, again, is keeping track of how many variables we have. Even when we have subtraction going on, even when we have negatives happening, if I've got 10 oranges and I take away 3 oranges, I have 7 oranges. It's a little bit harder to think about that when you have negatives involved, so we'll skip the orange analogy for that one. Let's get a little bit more work on these with some slightly harder problems. Exercise number 6. Rewrite each of the following by combining like terms and numbers. Show your manipulations, rewrite subtraction as addition when needed. All right, this is great. So let's take a look at letter A kind of in depth. Letter A, I just want to point something out. It's got 1, 2, 3, 4 terms, right? This is a polynomial that's got 4 terms to it. 1, 2, 3, 4. Remember, terms are separated by addition and subtraction, right? So I've got a 5x and a 9x. Those are like terms. And then I've just got a 2 and a 4. If you will, those are also like terms because they don't have any variables attached to them at all. Now, in order to kind of think about this, what I might do is I might use the commutative property of addition to flip-flop the 9x and the 2, right? So maybe my first step might be to rewrite this as 5x plus 9x plus 2 plus 4. And the associative property now says, well, I can group my addition like this. Now don't get me wrong, I'm very much hoping that most of you can now say 5x plus 9x is 14x, right? I got 5 oranges plus 9 oranges, I have 14 oranges. But if you had to, you could certainly still write out this step, 5 plus 9 times x, plus, and I think I'm just going to make that 2 plus 4 into a 6, so I get 14x plus 6. Many people will be good enough with their algebra eventually where they can take a look at this and just go, oh, I got 5x, 9x, that's 14x, I have a positive 2, a positive 4, and that's a positive 6. And that's great. Things get a little bit trickier when you have some subtraction involved and when you have negatives involved. So let's take a look at this one, right? 3n minus 1 plus 8n plus 5. Now, in order to kind of do this commutative property with the addition, right, we have to have addition. We can't really have subtraction. So, one thing I might think of first when I look at this is I might think of it first as 3n plus negative 1 plus 8n plus 5. Because I've rewritten this now as addition, I can now kind of flip-flop and I can say, that's 3n plus 8n plus negative 1 plus 5, right? Rewriting subtraction as addition of a negative allows me to use the commutative property of addition and switch the order of addition. I can switch this negative 1 plus 8n to 8n plus negative 1. That's the commutative property of addition. And now I can say, well, I've got these two and these two, so 3n plus 8n is going to be 11n. Negative 1 plus 5 is going to be positive 4. So I have 11n plus 4. All right, simple enough. What I'd like you to do is pause the video and try letter C for yourself, and then we'll go through it. Again, we've got a lot of subtraction here. We can change it all to addition of negatives. So I can make this negative 2y plus 7 plus negative 6y plus negative 3. And the advantage again of all that addition is it allows me to do things like this. I can now flip-flop that middle addition to make it negative 2y plus negative 6y. Then I can do plus 7 plus negative 3. These two now, when combined, I've got a negative 2 and a negative 6. When I add those together, I get a negative 8y, and then a positive 7 and a negative 3 combine to be a positive 4. And that's it, right? So we use all sorts of properties when we're doing manipulations like this. We're really using things like the associative property of addition. We're using the distributive property in order to really combine those like terms. All right, and it allows us to take fairly complicated expressions. And remember, the idea is you give me a value of y, like y equals 2. If I plug it into this expression, and I plug it into this way more complicated expression, we'll get exactly the same value out. All right, and that's going to be critical as we move forward. So today we did look at one of the most useful things in all of algebra, which is how to combine like terms, how to take something like 3x plus 5x and, quite frankly, make it into 8x. And it should make a lot of sense to you, right? But things can get tricky with variables and thinking about how they might combine. Can I say x plus y is 2xy? No, I can't. It's like adding a cat and a dog. You can't do it. So you really kind of have to understand this idea of coefficients, like terms, and then how to combine those like terms. We're going to use it a lot in coming lessons. For now, I just want to thank you for joining me for another NGen Math 7 lesson by eMath Instruction. My name is Kirk Weiler, and until next time, keep thinking and keep solving problems.